everyone. My name is Professor Sarah Goodman, and I'm a faculty member here at Stevens Institute of Technology in the Department of Chemical Engineering and Materials Science. And I'm excited to share with you today a little bit about what chemical engineering is. And so Stevens is a research university in Hoboken, New Jersey, and we have a Department of Chemical Engineering here. And so that's why I'm excited to tell you about what chemical engineering is. But to give you a little bit of background about Stevens, we have a beautiful campus in Hoboken that is right across the river from New York City. We have about 4,000 undergraduate or college students, and we have about 4,700 graduate students working on their master's or PhD degrees. And so what is chemical engineering? I think many of us have heard this term chemistry and the term engineering, but when you put those two together, what does that mean? Well, chemical engineers design processes to transform, transport, and produce materials, and they work on the production and manufacturing of products through chemical processes. But what does that actually look like? What this really means is that they figure out how to take processes that were developed in the lab on a very small scale and scale them up for real-world applications. Because many of the innovations that happen in the lab are being produced at a really small scale. And so it's up to the chemical engineer to figure out how to mass produce these chemicals or these products so that they're available to many, many people. And in order to do that, chemical engineers design equipment, systems, and processes for refining the raw materials and turning them into those products or those chemicals that we want. And the skills that chemical engineers use, it's not just about chemistry. Chemical engineering involves biology, physics, math, coding even, because chemical engineers often simulate a process before carrying it out in real life. It involves engineering skills. So if any of these are subjects that you're interested in, then chemical engineering could be a really great fit for you. And there are so many industries that hire chemical engineers. I'm going to talk about just a few of them today. And I want to start with pharmaceuticals and biotechnology. Chemical engineers help to develop these manufacturing processes to mass produce pharmaceuticals. They work on improving drug stability, and they even work on bioprocesses to produce therapeutic proteins, enzymes, and vaccines, for example. And a couple of examples of companies that hire chemical engineers are Pfizer and Merck, and those are actually located right here in New Jersey. Environmental protection is another area where it's really important to have chemical engineers involved because chemical engineers figure out the technologies for capturing and treating air and water pollutants, which are often products of industrial processes. And one example of chemical engineering in action in terms of environmental protection is the catalytic converter in your car, which is shown here in this image. And the catalytic converter takes the harmful pollutants from your car and it converts those into less toxic gases before releasing them as exhaust. And this is a mini chemical reactor in your car that's working to make the environment safer, and it's enabled by chemical engineering. The semiconductor industry is another example of an industry that hires chemical engineers. And you might think that this is exclusively the domain of electrical engineers, but actually the processing and fabrication of microchips requires many chemical processes like lithography, chemical etching, chemical deposition, chemical polishing. These are all processes that chemical engineers develop and figure out how to scale up for the production of microchips. And companies like IBM or Intel would hire chemical engineers to do exactly that. Consumer goods and cosmetics is another area that hires chemical engineers because we need people to formulate the products that we use every day, like shampoos, lotions, detergents, cosmetics, and even different food products. So chemical engineers work to increase efficiency in these manufacturing processes and also implement sustainable practices within these industries. And Procter & Gamble and L'Oreal are two examples of companies in this area that would hire chemical engineers. And alternative energy, I think we all know how important this is, but this is another area where chemical engineering is super important. because chemical engineers work to design these fabrication processes for solar cells, for example. They work on catalysts for fuel cells. They work on energy storage technologies like batteries. And they also work on developing biofuels for transportation, such as green diesel and sustainable aviation fuel. So these are just a few of the many, many areas that a chemical engineer could work in. And just to summarize what we talked about here, when we think about what chemical engineers do, it is really this idea of scale up, the idea that many exciting things are happening in the lab, but they're happening at a small scale. And it's up to the chemical engineers to figure out how to take these processes on the small scale and scale them up so that we can produce mass quantities of these chemicals and these products that we need so that many, many people can have access to them. And it's not as simple as just adding more materials. There's a lot that goes on in the scale up process. And in order to do this, chemical engineers design process plants to produce these chemicals at an industrial scale. So if any of this sounds interesting to you and you're wondering what the next steps are to become a chemical engineer, well, we think a great next step would be to major in chemical engineering in college. And so again, we're Stevens Institute of Technology and we have a Department of Chemical Engineering. And you can check us out on Instagram. Our handle is Stevens_CEMS. So you can feel free to reach out to us there if you have questions about chemical engineering, becoming a chemical engineer, or majoring in this field. Up next, you are going to hear from Pam Chang, who is a graduate of Stevens from the Chemical Engineering Department, and she's going to share her work as a chemical engineer on the COVID vaccine. And then after that, you'll hear from a couple of current students talk about their experiences in our department and with chemical engineering. Thank you so much, everyone.
Innovation is the core of what we do at AstraZeneca. Throughout this pandemic, we have witnessed what innovation can do in the fight against COVID-19 in our company and around the world. Chemical engineering students, these are things that one of these days you might be dealing with. So what is that manufacturing process? So we start with fermentation with a human cell line, okay? And we put this in a bioreactor and we let infection, it replicates, take place. And then we harvest the cells, right? And what we call the drug substance. And then we go through a purification process, very elaborate purification process. And then we yield what we call the drug substance, which is the active ingredient, if you will. And then we take that and we formulate it and we fill it into multi-dose vials. And then when you go to your doctor, your clinics, when you have taken a vaccine, you see the doctors takes out the vial and they draw that and vaccinate you. That's exactly the presentation that it will come in. Engineering solutions and passion to do our part have really guided us in creating what we call the formulation and filling capacity at one of our internal sites in the United States in record speed and efficiency. And for those of you engineering students, pay attention to this because this is the exciting journey, career that's waiting for you. That's what we do in real life, and what we do in terms of harnessing the capability of engineers that we have within AstraZeneca.
my name is Rian, and I am a senior chemical engineering major here at Stevens. It is currently January of my graduating year, and in about 5 months or so, I will have graduated with my bachelor's in engineering. One thing that I truly love about the chemical engineering program here is that classes are small, the professors are easily accessible, and the work is relevant to industry, hands-on, and interactive. If you take a look next to me, this is part of my group's senior design project. It's an industry-sponsored hands-on project. If you decide to come here and pursue chemical engineering yourself, you might be able to work on a project like this. Another thing that I really love about Stevens in particular is the location. We are located in Hoboken, New Jersey, right across the river from New York City, and there are plenty of job opportunities available. I myself already have a job lined up for after I graduate with a major industrial firm. Another thing that I love about Stevens is the ability for students to participate in research groups. For example, I've worked with various professors doing lab work and conducting research under their supervision, and opportunities to become a TA, a teacher's assistant, or a course facilitator for various classes, both chemical engineering specific and non-chemical engineering specific. So if you decide to come here and pursue chemical engineering, you are going to be in good hands. I can assure you that, because there are plenty of opportunities for you to grow. Thank you.
Hi, I'm Izzy Furyk, and I'm a senior studying chemical engineering at the Stevens Institute of Technology. One of the unique things about Stevens is that there's lots of opportunities for undergraduates like me to join research labs and work alongside professors and graduate students on really interesting and important research projects. I'm talking to you today from Professor Alyssa Hensley's lab, where I'm an undergraduate research assistant. We do computational chemistry, where we use supercomputers to create models of chemical catalysts on a very small scale, and design new kinds of materials that can make things like electric car batteries more sustainable. Working with Professor Hensley introduced me to a whole new side of chemical engineering and gave me so many exciting opportunities. Last summer, my work in her lab led me to an internship with Sandia National Lab in New Mexico, where I got to mentor with leading experts in machine learning models, publish a real scientific research paper, and see the Grand Canyon for the first time. Being involved with research as part of my undergraduate education has been such an amazing and unique opportunity, because many universities don't offer these kinds of experiences to undergraduate students, and it means that I have valuable experience that graduates from other universities don't. Stevens also makes it easy to get real-world experience on the job through the Cooperative Education Program, which I took full advantage of. I had 3 cooperative education experiences. 2 were with a division of the oil and gas company BP, and the 3rd was with Avon Cosmetics. These experiences introduced me to professional and laboratory environments that will look great on my resume after I graduate. Thanks to all of the great hands-on learning I've done at Stevens, I feel really confident that I'll be comfortable when I find my first job after graduation. Another great thing about Stevens is its small class sizes. Most of my chemical engineering classes have about 10 to 30 students, so I get more one-on-one attention from my professors and a more personalized education. I know everyone in my classes by name, and some of my closest friendships are with other students in my chemical engineering classes. I wouldn't have it any other way. Lastly, I want to tell you about Stevens' Accelerated Master's Program, which helps you earn your bachelor's and master's degrees in less time, just 5 years. If you choose to pursue your bachelor's at Stevens, you can apply to be part of the program and start earning credits towards a graduate degree during your undergraduate studies. My friends who have participated speak very highly of the program and have received higher starting salaries out of college. Choosing to pursue a degree in chemical engineering at Stevens has undoubtedly been the best decision I've ever made. I couldn't have asked for a better college experience.